Hello. Welcome to the second to last week of Art 107. Hi, everyone. Let me make sure we're recording. We are, but we don't have the podium as part of that. Let me get that zoomed in. Okay, there we go. So I think I'm certainly ready to get started. So as we begin today, we're obviously, according to the good old schedule, we are working on code. Specifically, I'm going to be looking at that Intro to Coding for the Arts Part 2. We're going to be pulling some coding concepts out of that. This one right here. So before I jump into all of this, I'm curious if y'all have any questions moving forward about, P5, about the class in general, or possibly even about the final exam. All right, I will proceed. Oh yeah, a question in the back. So there will be questions about code. The questions will not be quite that open-ended. So a code question might be something like, I'll give you an example of what a code question might be. So a code question might be something like that, and then maybe I'll put what I do in the code questions is I actually highlight sort of a point in the code. And so there's a code question that reads pretty much exactly like this, where I say in the question, what is the value of x at this point in the code? And so here we're giving x an initial value of 0. That's not the correct answer. We're then giving x the value of 100 here. So at this point in the code, x equals 100. One thing that I would really encourage all of you to do with the code-based questions, every single one of the code-based questions can actually be answered by cutting and pasting the code into the editor. So for example, if I was asked the question, what is the value of x at this point in the code, I could come in here and just say print x. And then by doing that, I would get a really good idea of what the correct answer is. So that's probably like the best way to deal with the code-based questions. If you have any, if there's not, it doesn't immediately come to your mind, like what the correct answer might be, you can actually kind of get in there and find out. Yes, question back here. Yeah, so the format is multiple choice or short answer. And so the short answer might be something like x equals 100 or something like that. But yeah, it's not like, it's pretty much all short answer and multiple choice. And pretty much identical to the midterm, except some of the code questions are multi-part. So maybe one question would be something like, what is the value of x at the bottom of the code? You may also, there might be a second part to that question that would say something like, it's hard for me to think off the top of my head what that might be, but something that's related to some other point in the code. And so there would be multiple answers for that. So I think that the code questions actually, because you have this ability to get into the editor and actually test them to make sure that the answer is correct, those technically should be some of the easiest questions if you take advantage of the tools that are available to you. Okay, so let's let's move on. So I'm going to just hit Control Z a couple times to kind of undo what I did to this. So today, I definitely want to spend some time talking about for loops. And so we've spent quite a bit of time in the last two classes sort of thinking about what we call logic control. That's a fancy way of talking about if statements. So we've had a couple of if statements that we've encountered in some of the example code. Right now, we'll continue to work with if statements because they're just a kind of a pretty important thing that you have to use fairly frequently. I want to kind of move into this sort of purple section where we're talking about something called iteration. And so, also, full disclosure, I have a bit of a upper respiratory thing. I got tested for COVID yesterday. It's definitely not COVID. And I'm going to keep my mask on, so I'm fine. Anyway, one of the things that computers are really good at, just kind of on their own merits, is repeating things. And so we have this example here where I've gone ahead and just set up an ellipse. And it looks like that ellipse looks very much like some of the other ellipses that we've played with. It has, a 100, 100 location, except this Y location is getting progressively further down in numbers because we're adding a product of 10 and the numbers 1 through 10. So this sort of number could be, pretty much anything you want. It just happens to be multiples of 10 right now. Remember how I said something last class about multiples of 10 are like the easiest? I mean, it's true, they are. So what's wrong with this approach? This may be an approach that a lot of you have taken with the first assignment, because the first assignment assumes that you don't know how to make a loop. So what is a loop, you may ask? Well, a loop is a way of taking something that you would write out in some kind of multiple. In this case, I believe we have a multiple of 10, 10 ellipses here. And it's a way of taking these 10 lines of code and making them much more efficient. And I'm going to use another big fancy technological word, making them much more extensible. So what does that mean? Well, it basically means that we can come up with a way to draw these ellipses in a way that, number one, uses less code. That's good in general. Number two, it's going to be more extensible, meaning that this ellipse and the way that it's drawn is going to have parameters that can be adjusted on a kind of like global level rather than having 10 things where you have to change each and every little thing. So we're going to take a look at sort of the difference here, and we're going to talk about the anatomy of a for loop. Speaking of questions that are going to be on the final exam, just looking for the correct slide. So this would be a good line or a good slide to kind of really look at. I'm actually going to add some information in here real quickly. I'm pretty sure this is also on another slide, but I want to make sure that you can access it for the final exam. So and then, let's see. And actually, I think we used the language test in the final. So that's some sort of like freebie Easter eggs for the final exam for you. I'm sure they're also on some other slides, but I want to make sure that they are sort of covered in the PowerPoints. So what we're doing in this case is we're going to make a for loop out of these ellipses. And that's going to cause us to use 3 lines of code instead of 10 lines of code. So let me go ahead and get started. I'm going to start with just 1 ellipse. So I'm going to cut and paste that. And I'm going to start this ellipse at a different x-coordinate, just so we can kind of get it over on the side here. Now, that's great. I've drawn one ellipse. That's not maybe super exciting. I'm giving myself just a little bit of white space. And I'm going to go ahead and make a for loop. So in order to sort of explain the for loop, I think I really just need to kind of go through it step by step. So there are 3 parts to a for loop. And a for loop, unlike something like the draw loop, a for loop contains some stuff inside the parentheses that is hypercritical to its functioning. So you cannot make a for loop without doing these 3 things and having them the way you want them to be. So the first thing we're going to do is we're going to create a local variable. And I'm going to talk a tiny bit about what a local variable is as we kind of undergo this process. So I'm going to say for I equals 0. And then I'm going to say something like I is less than height. Sure, why not? And then I'm going to say something like I plus plus. It's going to make it really easy and straightforward here. So I do need to have these curly braces sort of surrounding whatever it is that I want to have the for loop repeat. So in this case, the for loop is going to repeat this line of code a certain number of times. Now, let me go ahead and just draw something to the console. So I'm going to print the value of I to the console. And you should see pretty clearly what happens. So there is our I number. And what has happened here is that we have kind of opened up an awful lot of iteration. So let's kind of go through this, okay? So there's three things that are happening here to cause I to go all the way up to 400 in this case. It just so happens, by the way, that our height is 400, so that's why it's going up to 400. Here, you can see that our variable I was created at 0, right? Pretty straightforward there. Now, what it's going to do to I is when it declares I equals 0, it then says, is I less than height? Is 0 less than height? I hope so. Yes. Right now, 0 is less than height. Height is 400. So then if I is less than height, then you'll go to the next step, which is the increment, or in some cases the decrement, or you can actually use any math operator you want in there if you want crazy stuff to happen. Most people just want increment and decrement. Those are the most common. So we're calling it using the increment operator here. That's the double plus plus. So it's adding 1 to every time it goes through the loop. So what would happen if I maybe changed I plus plus, which is going to add 1 to I, if I made that I plus equals 10? If I use the right character here, it would be helpful. So just waiting for it to show up in the console. It seems like it's running a little bit behind. Might be helpful for me to have a semicolon there. Oh, it doesn't like my semicolon. That's about right. So fantastic. It's cooperating a little bit better now. So that's fantastic, and that's exactly what we would expect. So here, it's starting at 0. it's 0 is less than height, and then 0 gets 10 added to it. Okay? So then this declaration stops after the first loop. It doesn't have any effect on the thing. After the first loop, after it's gotten 10 added to it, it goes back and it tests it for height. And then it says, yes, 10 is less than height, so I'll add 10 more. And it's going to do that probably like 40 or 50 times until it gets all the way up to 400. And then it's going to say, is I less than height? Well, it just so happens that I was close to 390 or 400. So no, it is not less than height. At that point, the for loop ends, okay? And in general, one of the worst things that you can do with computers is to make a for loop that never ends. I'm not going to do it because I don't want to restart my computer right now. But if you make a for loop that never ends, which would be something like, maybe, that would be a for loop that never starts. Maybe something less than or equal to height. So if I typed that in, it would test as true when it got up to 400. And in fact, it would actually potentially keep going. So in general, I would just kind of try to think through your for loop and conceptually make sure that it does have an ending. What happens if you write a for loop that doesn't end? Well, you'll probably have to end task on your browser or go to force quit if you're lucky. If you're not lucky, you might not even be able to force quit. You might just have to do a hard restart of your machine. This is not an urban legend. It's actually true. I have seen people who write never-ending for loops, and your computer can actually overheat itself. So it is a true thing. It's sort of not something that most people would do because, usually you would get to the point of restarting it before that happens. But yeah, watch out. Okay, so now that's great. You might be like, okay, Meg, I think I maybe understand how these numbers are going up and down, but my ellipse is just still sitting there. It's like, nothing's happening to my ellipse. I did not get what I paid for. Give me my money back. Okay, well, maybe that might be true. How could we get the ellipse to reflect some of this wonderful up and down number data that we're starting to generate with the for loop? Exactly. Yeah, exactly. So we have to put the I somewhere in the ellipse in order for that changing number to sort of have effect. So let's try maybe adding I in this slot where that's a capital I, a lowercase I. So yeah, let's try just adding an I in this spot where I started to have that scalar value for the, oh, hello. So I'm going to have to think about this for a second. Okay, let me try running it one more time. Hang on, sorry, huh? Oh, yeah, so true. So when I was playing around with this, I actually went back to the option, and this is actually a really good opportunity to talk about a for loop that never runs. So what is wrong? It's actually not the problem. Me putting the I here wasn't really the problem. This for loop that used to work doesn't work anymore. And if I run my program, you might notice that I is not ever printing to the console. That's not happening. Why is that not happening? That's not happening because right now the entire for loop is not happening. What's happening in the for loop is that I'm instantiating I to 0, and then it's saying, is I greater than height? No. And so then what's happening? It's like, I'm going to curl up and die now and not run. It's done. It tested negative on the logic test. So I was actually looking for, is I greater, less than height? So greater than and less than will get you every time. So, okay, so that's fantastic. It looks like now I have this sort of like awesome iteration of circles. Um, I mean, a couple of things we could try now to kind of like make this like a somewhat richer experience. Probably one of the things that I would want to know is, well, how do I make it exactly the same as the other series? And so the other series, it looks like, is actually capping off at 100. So I could certainly make I sort of less than or equal to 100. I think it needs to be actually less than or equal to. And so now they're exactly the same. So I basically just changed the scope of the for loop. Of course, we can also have like a go back to height here. We could also try the amount that we increment the for loop. We could turn that up or down. So right now, I'll switch back to doing it with the individual sort of thing. Here you can see that when you iterate things with just a 1 as a unit, it's a perfectly reasonable thing to do. It does create a sort of situation where you have objects that are extremely close together, right? Because they're only 1 pixel apart. So one way to get around that would actually just be to add a multiplier of 10 down here. And the reason that you might want to just do that is just to space out the objects. And so then we have the spaced out objects. Also, I'm just going to quit some applications because my laptop is a little bit, it's a tad slow. When you're having trouble like drawing ellipses to the screen, that's definitely a sign that you might need to quit some applications. Okay, so yes, please save. Okay, so we're back. So what kinds of other interesting things can we do to this? Well, I mean, we could certainly think about maybe doing some of that fun color action that we had before. So I'm going to do the color mode. I'm going to choose HSB, and I'll also do it with a range of 100. I think I'll make a variable for color up here like we did last class. And so maybe in here I have some kind of a fill where I is actually the hue, and then the saturation would be full on, which would be 100 actually. In this, and the brightness would also be at 100. So you can use that I to affect color. It's not me, it's my computer. It's just being really slow. So once again, I think this would be a great place for like a no fill. Hopefully my computer will catch up with whatever it thinks it's doing besides heeding my will. Yeah, apologize for that delay. So anyway, yeah, the point is here, instead of using 100, we're using it for a lot of things. We're using it for the y coordinate of the ellipse. We're also using it for the fill. We could even maybe come in and use it for the various sizes of the ellipse. And you can kind of go crazy with for loops. I mean, I personally think that for loops are, wait for it, I hit the refresh button like maybe 60 seconds ago. I think that for loops are probably one of the most powerful tools in code and in computing in general. A lot of people might say, or you might think to yourself, well, is it really that important that I use a for loop? When you have 10 items to draw to the screen, that's a really small number in computing terms, right? That's like hardly anything. That's like maybe you have a penny or two in your pocket, right? If you're doing something like data visualization or working with even like a file that has, node information or something like that, you could have 10,000, 100,000, more data points that you actually have to, assign something to or find something about. And so that's really kind of where for loops come into play. There we go. There's my refreshed version. And so you can see here we're actually starting to use, that for loop to kind of illustrate scale. One other thing that I want to kind of point out to you in terms of for loops is that you can also nest for loops. So there's some examples from most of the concepts that we're talking about this week are in this, oh, for God's sake. I'm sorry, everyone. I don't want to break into my own data, That would be terrible. It's right here. So there's plenty of examples of both iteration with for loops and then also the logic control. This would be exactly pretty much identical to what we've done in class for the last couple items. So those are sort of some places where you could look for it. When I say that you can nest iteration, what I'm talking about is the idea of making a grid. And so that's this example, which we can take a look at. I can actually kind of just make it from the ground up. But what you're doing is you're basically taking one for loop, and you're taking one for loop to itemize the columns. This is starting to sound an awful lot like a table. You're itemizing the columns with one for loop, and then you're itemizing the rows with another for loop. And so that's what this example does. I think I'm going to go ahead and kind of work this example into this more complex example, and we can kind of just go from there. So basically, I think for now, I want to fill this with white. Actually, it doesn't matter. I'm just going to focus down here. So we've got this one for loop that is working pretty well right now. I don't need to print anything to the console because I'm confident that it's doing exactly what I want. What I could do here is I could go ahead and take this for loop and wrap it in another for loop. So what is that going to look like? Well, it's going to look like something like this. Now, what's going on here? Well, the inner for loop, I'm actually going to preserve this inner for loop as a thing all by itself. So in this case, the inner for loop is making this thing where it's starting at the top and it's going downward, right? So what we want to do is maybe think about how we can take this for loop and take it and replicate it itself. So what does that mean? Well, what if we just maybe try to go up to 10? And then here we do plus plus. That seems legit. Guess what? This is going to enter up an error as soon as we run it. And the reason is because we need to make this variable something other than I. So I'm going to choose J. That would result in a sort of conflict. And so now I should be able to just go ahead and run it. And my prediction is that literally nothing will happen. And the reason that nothing is happening right now is because we are not really doing anything with J. So what would we need to actually do with J? Well, let's see. Probably coming up with something like making the x coordinate related to J could help us. So in this case, maybe I would do something like, let's just try subbing J in there and see how far we get. it might take a minute. While I'm waiting, I'll close some applications. Okay, so probably a good question to ask at this point is like, what is the value of j? So I'm gonna, instead of printing I, I'm just gonna print j. The value of j, my sort of common sense, spidey sense tells me that it's somewhere between 0 and 10. If it's not somewhere between 0 and 10, we're in a really tough situation here. So I'm just going to adjust these numbers to something a little more realistic. Maybe this number is something like width, and this number is something like plus equals 10 or even 100. So let me make sure we're working with the same code here. So I might actually have to restart my computer, y'all. This is terrible. Let me just double check and make sure that there's nothing else taking up a lot of space here. So one other thing that I'm going to do, just short of sort of restarting my computer, I'm going to open a new Chrome window and try to run my sketch in that. There we go. Yay! Okay, sorry about that, everyone. Yeah, in general, when you're working in P5, you should not be spending that long waiting for your sketch to run. That's a sign that like something might be wrong. So anyway, as promised, we have our sort of J app coming through these other repetitions of repetitions. And so what the J loop is basically doing, or this J variable, is saying, okay, J equals 0, J is less than or equal to width, obviously, and then we're going to iterate it or increase it by 100 every time it goes through the loop. So right now, our limiters on this loop are width and height. Somebody might notice that I've used that a couple of times in different code that we've written. Why is that a good thing to do? It depends on what you want out of your code, but if you want to maybe present this on a computer that has a lot of power with a great graphics card that can display all the pixels, you can make the width and height larger. And the code will sort of reflect that when it eventually draws it to the screen, which clearly is not a great day for me to demonstrate that. But yeah, that's basically why I tend to put width and height in these areas of my code, because it basically makes the code responsive to the size of the window that you draw. And in general, not having to go back and hunt and peck through your code to change numbers is good. That's effort that you don't really want to put into it. So I'm going to take 10 off of here just to put them a little bit closer together if they ever draw to the screen again. And just going to double check and make sure that I don't have, this is really pretty simple code. There's no reason it should be so slow. I'm going to just mute the projector for one quick second and see if I can close some of my browser windows as well. I've never answered the question, how many tabs can you have open in Chrome? But I have tried to answer that question before. And pretty much the answer is many. You can have many. So it looks like we're still sort of pretty laggy. Another good thing, this is like troubleshooting with Meg. Another good thing you can do when you're sort of troubleshooting is, you can check to make sure your storage is not full. Oh, actually, that might be my problem. So obviously, I've been capturing a lot of video. So this 46.5 gigabytes on a 500 gigabyte hard drive, that's definitely like well into the danger zone. I try to keep at least 100 gigabytes of free space on my drive at all times. So every like 2 or 3 weeks, I clean video off of my computer. So that might be part of it, but it shouldn't be necessarily causing this level of brokenness. Let's see what else we can do here. Yeah, I think I have completely lost my... Well, there was one thing that I wanted to show you relating to for loops that we kind of didn't get to yet. Oh, it's going to do it. Good. Nice. Okay, so this is what I was looking for. So basically now it's generating one of these for loop stacks at every 10 pixels. And it's filling up the width of the screen. It's kind of fun. What else could we do to like kind of take advantage of all of this, nice sort of range of numbers that we have being generated? We're generating numbers 1 through 10, and we're also generating numbers 1 through 400. So probably, I think it would be really cool if we could maybe address rotation. So rotation in P5 is addressed in radians, which is, so a full rotation is actually 2 pi. That's so like 6.2 something. If you're one of those people that has like all the digits of pi memorized, good on you. Pi is actually a system variable in P5, so you can just write out pi in capital letters, and it will know what you're talking about. So, so in this case, let's just go ahead and maybe think of like some kind of like delicate level of rotation. So, I'm going to go ahead and rotate ahead of the ellipse call. Okay. So rotation in P5 by default, if you type rotate, it's going to assume that you want to rotate it on the x-axis. Oh, I can't even type right now. That's sad. Let's see. We've got 5 more minutes. Let me think about, you're gonna get an impromptu demonstration on how to clean a Mac. So yeah, go up to the Apple and then hit About This Mac. And then if you go to the sort of section where it talks about storage, you can click the Manage button. And it will just pretty quickly give you a sort of rundown of where all of your files are. So I'm going to take a few of these like really big ones and just get rid of them. Especially class videos. So now I should be able to delete those. That's 9 gigs of storage. That actually should be enough to take care of my situation. This would be nice too. Okay, hopefully it might improve slightly. So it's over that 50 gigabyte threshold, which is nice. So, okay, please be more responsive. can do it. Yeah. Yeah, definitely hitting the stop button can help because otherwise it will draw constantly to the screen. That's a really good point. Okay. Okay, so rotation. So in general, in P5, you want to use really small numbers. What do you mean by really small numbers? Well, let's kind of think through this. We've got about 10 of these sort of sticks that kind of, are generated from this for loop. So 10 of those, if we rotated them and we wanted it to equal out to a full rotation, it would be, there's a mathematical way to express that. That would actually be 2 pi, which is a full rotation, divided by 10. So that would be one way to do it. We could just put in here 2 underscore pi and divide it by 10. That's not necessarily going to be the sort of way that I go about it for real. But that will definitely generate a result where it looks like they're sort of equally spaced out along a revolution, right? Another way of dealing with rotation is maybe thinking about dealing with it over time. So if we take rotation in here and just do it slightly differently, so I'm actually going to use a variable for rotation this time. And that can go up here. And then here you can see this is going to kick up an error. So the error or it's not kicking up an error, it's just not doing anything, which is almost as good. So here, why is it not doing anything? Well, this is a really great sort of example of variables gone wrong. I declared a variable up here. I should be like, oh, that's fine. It's great. Well, this has no value. So if I want it to have a value, then I have to assign it a value. So I'm going to try something like 0.0005. Okay? And so now I should get this equal to 0.0005, sort of. And then if I wanted to maybe keep that moving, I could take at the bottom of my for loop and actually completely outside of the for loop, but still in the draw loop, I can just add some stuff to the value of rotate. And so I would say maybe something like rotate plus equals 0.005. Why do I like to rotate things by 0.005? 0005? I don't know. It's just a nice small number. And so what you would be able to see if my computer were sort of working correctly is that these would be moving like pretty slowly. And in fact, adding an extra 0 would help if I added an extra 0 there. So your homework assignment, informal homework assignment, I'm being kind of a little cheeky, is to run this on your own computer where it will most likely run much better and more smoothly. But it should be this kind of like very smooth sort of constantly rotating, constantly melding, brightly colored thing that we just made out of a couple of ellipses and some sandpaper and some, whatever else. Yeah. So, yeah, definitely by the next time you see me, I will have restarted my computer. So I'll just leave you with that. I'm posting the code every day, by the way. So there's code. Again, it should run much much better on your computer. But I'm posting code along with the sort of like daily activities. So yeah, look for that. And next week is going to be all about interaction and how we can use the mouse and the keyboard to really get some responsiveness going with, the various input devices that we have attached to our laptops. So I will see you all next week. Have a fantastic weekend. May the weather be above freezing. Bye, y'all.